For the 51st problem on the second ACT practice test, in teaching a lesson on the concept of thirds, Ms. Chu uses a divide and set aside procedure. She starts with a certain number of colored discs, divides them into 3 equal groups, and sets one group aside to illustrate 1/3. She repeats the procedure by taking the discs she had not set aside, dividing them into 3 equal groups, and setting one of these groups aside. If Ms. Chu wants to be able to complete the divide and set aside procedure at least 4 times without breaking any of the discs into pieces, which of the following is the minimum number of colored discs she can start with? So with this problem, there are 2 methods that I can see to approach it. One is sort of an intuitive and fast approach, while the other is logical, but it's slow. So let me show you the fast approach first, and then I'll show you how to logically prove that that's the correct answer. So basically, the fast way is to just look at these answer choices. We know that we have to be able to divide our set of discs into thirds at least 4 times. So we have to decide which of these numbers could be divided by 3 4 times and still be a whole number. And you can test this by just picking a number at random, like 54. If you just repeatedly divide that by 3, you'll eventually end up with a fraction by the 4th division. But a number like 81, this is actually 3 to the 4th power. So we know that this is divisible by 3 4 times repeatedly. So you can conclude from that argument that choice letter E would be the correct answer, since this is the only number that would work. Now, I did say there's also a logical approach to essentially prove this. And this approach works, but it is a little bit slow because what Mrs. Chu is doing is a little bit complicated. So she's going to start with some set amount of discs and then divide them into 3 equal groups. So let's say that this right here is our pool of discs. And let's say we have D discs. And we're trying to figure out what this number D is, essentially, or a possibility of what D could be for this to work. And from here, she's going to divide this group of discs into 3 equal groups. So we'd have one group here, one group here, and one group here. And then to demonstrate the concept of 1/3, she's going to take one of the thirds, or one of the groups, and set it aside. So this is just to demonstrate the concept of 1/3, or to illustrate 1/3. And then next, what she's going to do is to essentially recombine these groups. So she's going to repeat the procedure by taking the disc she had not set aside, so that's these 2 groups here, and then divide them into 3 equal groups. And once she does that, she's going to again set one of the thirds aside. So essentially, we're going to recombine these into one group again, though smaller now. And this recombined group, let's think about how many discs are in here, or at least relative to our starting point, what fraction do we have left here? And if we took away a third here, then there should be 2/3 between these. So recombining them, we now have 2/3 of the discs. But like I said, she's going to redivide these into thirds again. So now breaking them up into 3 separate pieces, essentially you're going to be dividing this by 3. So we have 2/3 of the discs, and now divided by 3. And dividing by 3 is essentially just multiplying this denominator by 3, since if you change this to a multiplication problem, it would become times, instead of divided by, 1/3. Since this is just 3/1, and changing it from division to multiplication, you just flip this. So essentially, this division by 3 gives 2/9 of the discs for each of these. And again, she's going to take one of them and set it aside. So then we have to think how much is left, because we're going to recombine these and repeat it all again. And if there are 2/9 in each of these, then 2 of these together would just be 4/9. So now recombining these, we now have 4/9 of the discs, and we're going to repeat the procedure. We're going to split this into thirds. So we need to figure out of our 4/9 of these remaining discs, what a third of this would be. So we divide by 3 again. And like I said before, we're essentially just going to multiply the denominator by 3 since we're dividing the whole thing by 3. So it becomes 4/27 of our discs, and each of these thirds that we've just split our pool into. So each of these has 4/27 of the original amount of discs. But as before, we're going to take one of the thirds and split it off, and then recombine these for one final procedure, since we're only doing this 4 times. So recombining these, now let's think about how many discs would be left in this recombined pool. Since each of these has 4/27, and we now just have 2 of them left, we would have 8/27 in here. So we just have 8/27 of our original amount of discs. And for the last time, we're splitting them into 3, which means that we have to once again take our remainder of discs and divide them by 3 so that we can split them into these 3 equal parts. So we're taking this 8/27 times d and dividing it by 3, which essentially just multiplies the denominator of this fraction by 3. And what we're left with is 8/81 of our starting amount of discs for each of these 3. So now we go back to the question. We have to think, what's the minimum amount of discs that we can start with, such that when we do get to this last step, breaking them apart, we'd end up with a whole number. So we know that whatever amount we start with, that at the very end, each of our divisions, those sets of 3 at the very end, they each have this 8/81 of our starting amount of discs. So out of the numbers available that could potentially be the right answer, one of these has to be the right value such that when we put it in here for d, we would not get a fraction. So for instance, if we picked 27, putting that in here, 27 divided by 81 would be 1/3. So we'd have 8/3 would be our total answer, but that is not a whole number. That has fractional parts to it. And basically, the only obvious choice at this point is 81. Since if you put 81 in here for d, then 81 divided by 81 would cancel out, and you'd be left with 8 whole discs left. And you could check for yourself, but the rest of these 4 choices do not work. So 81, letter E, would be our final answer.